So the last section allowed you to skip any calculator work because we were sticking to angles that are found in the special triangles, like pi over 4. But there are many more angles in the universe than just the 3 that show up in special triangles. So we need to be able to handle these operations when the answers aren't so clean and tidy and you have to actually use a calculator to answer them. So I can solve that immediately by just making this a 5. Right? Pi over 5 is not one of your special triangle answers. So in order to solve that, you're going to actually have to get out your calculator and you're going to have to type in pi divided by 5. And if this will behave for me, pi divided by 5 is broken. Pi divided by 5 is approximately 0.628318537. Now that's irritating. I don't want to type all of those digits. So I'm just going to keep 3 decimal points on my paper and all the decimal points on the screen here so that I'm not rounding. So sine of pi over 5 is the same as sine of 0.628-ish. If I hit the sine button on that and I make sure that I am in radians, how do I do that on this machine? Oh, there it is. There we go. So if I make sure it's in radians, I need to take the sine of 0.628. So I just have to push sine on my machine. Sine of the answer gives me 0.587785. Two, 5, 2, 3, and since I've already approximated, I might as well round this to a certain number. So the answer to this is 0.588. Now it's not 0.588 radians, it's just the sine ratio. It's like when you typed in sine 28, and 28 wasn't a nice special triangle answer, so sine gives you this horrible non-repeating decimal. So that's really all we're after. You might even see something in radians that doesn't look like a fraction of pi. Right? You might see sine of 2.431. Well, if you see that, you just have to make sure your calculator's in radians, type in 2.431, let's try 2.31, and then you take the sine ratio of that. So sine of 2.431 is 0.652. Ish. Now, there are rules for how many decimal places you're supposed to take, but we're going to be a bit careless, and we're just going to keep 3, just because it's a nice round number of decimal points. So, if you see a fraction of pi that is not one of your special triangle angles, you just type it into the calculator and get your answer. If you're asked to take the sine, cosine, or tan of a number that is not even a fraction of pi, that's okay. You just put it in your calculator and get it done. So we answered questions like this before in the last section. Sine of alpha is 1 over 2. And 1 over 2 was one of the ratios from the special triangles. So you didn't need a calculator to do it. But if I make this 1 over 12, all of a sudden, I don't have special triangles to use, so I'm going to have to use a calculator to accomplish this. But just like the special triangle ones, there's only 2 pieces of information I need. I need to know the family of angles that it belongs to, and then I need to select the two that land in the correct quadrant. So if I'm arc sining this, 1 over 12, you're going to have to type in 1 divided by 12 into your calculator. 1 divided by 12, which gives you approximately 0.83333. 8333 ... forever. If I hit the arc sine button of that, so shift sine is my answer, I get 0.08343. All right, that's my angle family. That's not my answer. So I have to construct the angle family. So 0 was here, pi was over on that side. In order to get the solution in this quadrant, I just had to take this number. So that's my first one, 0.08343. To get the answer in this quadrant, I had to go all the way around to 2 pi. And then I had to back up by the size of my family member. So if I take 2 pi and I subtract that, I end up with 2 pi, subtract the answer. I get 6.19975 something something something. The same way this was something something something. To get this family member, I had to go all the way to pi, and I had to back up this far. So if I do that, pi subtract 0.08343, I'm going to need to invest in a better calculator. Pi subtract 0.08343 is 3.058. Well, it's that if I round it to 3 decimal places. I think I told you to do that already. So this one, what's that? 6.200. This will be 0.083. Okay, our final family member, I have to go to pi and add that wedge. 0.83 gives me 3.225. So if you just check your numbers, pi is 3.14. So you should end up with one that's a little bit less than pi, one that's a little bit more than pi, one that's some value your calculator spit out, and 2 pi is 6.28, so you should have something that's a little less than 6.28. So there's my 4 family members. Now that I've generated those, I'm going to look at my cast rule. And I'm hunting for a sine ratio that is a positive number. So sines are positive here and they're positive here. So I want the 2 solutions that are in this quadrant and in this quadrant. So my alpha then would be 0.083 plus as many rotations as I like, or alpha is 3.058 plus as many rotations as I like. So this solution isn't any different mechanically from when we did the special triangle values. The only difference is that I needed a calculator in order to spit out that first family member so that I could proceed. So I'm going to erase this. We're going to do a cosine example and a tan example, and then you're ready for the practice problems. So this one didn't even bother to give you a fraction. It just flat out gave you a decimal value. So I'm going to go and I'm going to arc cos this, and we'll see what happens. Okay, so if I type that into my machine, arc cos of negative 0.8, I get 2.498, and that's rounding to 3 decimals. All right, now that's a family member, so I'm going to have to figure out exactly where that is. So if I were to draw those, pi is over here, 0 is here, and this is pi over 2. Now pi divided by 2, if you actually type it into your calculator, is 1.57, and pi is 3.14. So where is this 2.498? Well, that's more than 1.57, and it's less than 3.14. So it has given you a solution that's here. That's where 2.498 is. Now that's tricky, because we're used to seeing them show up in just first quadrant, but this one didn't behave itself quite the way we wanted to. Now I'm going to check my cast rule just to see why that is. So your calculator was smart enough to realize that because this cosine was negative, it needed to give you a solution that was in this quadrant up here. So it did. But now you need to be smart enough to figure out how to get this one. This is the other place where cosines are negative. So I'm going to add it to this diagram down here. So I have to get to this spot. How am I going to do that? I was told that this family member is at 2.498. So I can get to this one. Well, how am I going to do that? Normally I have a number that's less than pi over 2, and I just subtract it from pi, and then I add it to pi. Right? That's what we've been doing. But this time I have the wrong side. So you could take pi, subtract this number, that would give you the wedge here, add it to pi, and that would give you your answer. No problem. Or you could take 2 pi and back up 2.498. That would work too. I'm going to do both of those solutions just so we can compare the numbers. So option 1. Option 1 means I need to figure out this piece here. So that wedge is a full pi, subtract 2.498. So pi minus my answer gives me 0.644. So now that I know that this wedge is 0.644 radians, I'm going to add it to pi. So if I add that chunk to my full pi radians, I get 3.785. 0.644 is 3.785. That's my solution that is slightly bigger than pi, so that's one of my options. I could do it that way. Option 2. If I went all the way around to 2 pi, and then I backed up 2.498, you can sort of see it, right? This line, this location is symmetrical across the axis. If I subtracted that 2.498 from 2 pi, so 2 times pi is subtract 2.498. I get 3.785, which is what I had there. Now, that's a lot of work in order to find 2 family members, but fortunately, I don't have to find the other 2. I guess accidentally this one is 0.644 and this one is, who cares? Because the two I needed were the two that were in those two particular quadrants. So I'm done now. My answers to this, the angle that returns negative 0.8 as a cosine value is either 2.498 plus as many rotations as I like, or it's 3.785 plus as many rotations as I like. So the message here is you have to be careful with your calculator output, particularly when doing arc cos, arc sine, and arc tan. Once you mix negatives in there, the calculator sometimes, without your knowledge, pre-answers this for you. It spits out one of the solutions, not the smaller family member. So you have to think about your answer. If you've gotten something that's bigger than 1.57 and less than 3.4, it has given you the sine quadrant solution. So you're going to have to think about how to get this second one. So I have a tan function here just for a complete set. I'm going to have to arctan both sides in order to solve this. And like the other two examples and all the other ones in the special triangle, I'm going to have two root solutions plus as many arbitrary rotations as I'd like. So first off, I'm going to have to get my first family member by doing arctan of -1. So if I type that into the machine, -2.5, sorry, equals, and if I arctan the answer, I get -1.19. Now that's strange. It spat out a negative answer. So if I put these things on here, 0, that's pi over 2, which is approximately 1.57. This is pi, which is approximately 3.14. I've got a negative. Well, what do you do with that? Well, if we use the cast rule to try and puzzle this out, C-A-S-T, I'm after solutions where a tan ratio is negative. So tans are positive here and here, which means I must be after the solution there and the solution there. So what does the negative mean? Well, if you started at 0, and instead of going this way, you went the wrong direction, down to here, you would have -1.190. So this wedge, then, is 1.190 radians. So if I'm after the solution up there, I'm going to need the one up in this corner. And the wedge, between all family members, the wedge always matches. So if this is 1.19, then so is this. And so the solution I have up there would be go all the way to pi and then back up this 1.19. Excuse me, 1.95. 1.951 if I round to the right place. Okay, so the two solutions that I needed were in this quadrant and that quadrant. I have one, so my alphas are either -1.190 plus as many rotations as I like, or alpha is 1.951 plus as many arbitrary rotations as I like. Now this is maybe bad grammar. Maybe shouldn't be returning a negative angle. You should probably return a positive one. So I could accomplish that by going from this place and doing a full rotation. So I just have to add a 2 pi to it. If I were to do that, 2 pi plus negative 1.19 gives me 5.093. If you wanted to, you could call this one 5.093 plus as many rotations as you like. And then you wouldn't be returning a negative answer. Now that doesn't like, I'm not concerned about that. It's just good practice, or I shouldn't say good. It is traditional practice to not return your negative answer, to try and get this thing to be a positive. But it doesn't really matter. I mean, that solution is contained in that sentence there. So basically, if you come across a ratio that involves a number that is not a special triangle value, you're going to have to spit out the family members using your calculator. If the thing you're working with is positive, it's going to give you this solution. And then you have to construct the other three from it and choose the quadrants accordingly. If this number back here is negative, it might spit out one in that quadrant, and then you're going to have to be creative about how you flip it around in order to get the second solution. Or it might give you a negative value, which is generating the solution down here, which you're going to have to then think about how to place. So take that information and tread lightly with your calculator. Just because it gives you a number doesn't mean that's the number you need, or that you can just plug and play into a formula. You'll have to think about what that answer is and how to turn it into your second solution.